Hi there, just a quick explanation of what you're seeing on the screen. On the left-hand side is what the student will see, and on the right-hand side is the teacher's screen, as it were. And I'm just going to start by setting up the starter as the teacher, which is on Socrative. I'm going to start a quiz called Starter. I'm going to make sure that they can answer the questions, but the answers are all shuffled around and they can see their final score. I don't want to shuffle the questions on this occasion because the questions kind of flow in terms of sequence. So I'm just going to start that, and then on the student part, go to Socrative Students, type in the room name Socotra, and write in my name, I'm just going to say test student. And now the student has started the starter. So starts from asking them really basic questions about addition in decimal. Hopefully they get that one right. So I'm just going to flip through these. And as you can see on the teacher's side, it comes up with whether or not they've got it right and what their name is on the left-hand side as well. Question there about what's missing. I'm just going to purposefully get that wrong, and you can see there that you can see if people get it wrong. Just going to write in 10 there, an explanation of what they are in terms of those words and what the prefix DEC connects them to. So hopefully now the students all know that that's the number 10. And when they get asked this question, which is all about our number system and decimal, they'll be able to get that right, especially with that hint. Here is just one for them to just do as much as possible, really, just listing all the words they can think of that start with the letters BI, giving them an example as well. I'm just going to write test just there and submit the answer. Now, obviously, while they are answering all of those, and if they then submit it, I can see all of their answers here. If they've answered quite a lot on this one, I can actually click on the question there, and that's to show the names as well, just so I know who's written what. I can go down the list and maybe even talk about them while they're all writing it as well. Now that's over, the next part is to continue with the presentation. So, today we are going to talk about binary numbers. Our objectives for today are to understand the difference between binary and decimal numbers, to demonstrate how to convert from binary numbers to decimal numbers, and explain why binary is suitable for computers to use. But first of all, you might think it's a bit of a silly question, but how do humans count? How do humans count numbers? Well, to answer that question, I'm going to ask another. And that is, why 10 digits? Why in our number system do we use 10 digits? Well, I think it's because we've got 10 fingers. I'm almost certain that when cavemen started counting, that if they had 12 fingers to count from, that's what our number system would be. It wouldn't go up to 10, it would be 12. So now that we know that, and we know that our decimal number system works in tens, and again, this might be a bit of a silly question, but what number is this? And this is where I would ask one of the students to unmute themselves and answer that question. I would keep them on the line after they've said that it's the number 49 and ask them, how do we actually know? They may give me the correct answer, but they probably won't. I will then continue to say that we know that it is the number 49, and we do this automatically as human beings now because we have been working with the decimal system for generations and generations, and actually our brains do this automatically. But we know that the number 49 can be written out like this, as 9 units, 4 tens, 0 100s, and 0 1000s. So we could go on forever, but we know that all of those are going to be zeros. So all we need to concentrate on is the 9 ones and the 4 tens. So why is this known as the decimal system? It's known as the decimal system because we multiply each column by 10 each time. Hence, decimal. So we go from 1 times that by 10, you get 10. 10 times that by 10, you get 100. You times 100 by 10, and you get 1,000. In the decimal number system, each column can only contain numbers from 0 to 9. Not 0 to 10, because that would actually be 11 numbers, because 0 can be counted as a number 2. And if, let's be honest, we tried to write in 10 in the units column, it wouldn't let us really. It wouldn't make any sense. You can't write 10 in the units column. That would sort of carry over into the tens. So you'd have 1 10 and 0 ones. So again, this might seem a little bit silly to start off with, but bear with me. If we're going to actually work out what the number 49 is, again, we do this automatically in our brains. We actually do this calculation. We know that there are 9 lots of 1 and 4 lots of 10. And when we do that calculation, we know that it is the number 49. So now that we've figured out how humans count, I've got to ask the question, how do computers count numbers? They don't have 10 fingers, so how do they do it? Computers and their processors, which is the tiny little chip that they have inside, are made up of billions and billions of switches called transistors, which can either be on or off. So any old switch, you know that when you've got a switch, it can either be on or it can be off. Those are the only 2 states that a switch can be in. So if we were going to represent that in binary as ones and zeros, it would make sense to represent that as 1 for on and 0 for off. I'm going to ask another silly question. What is the proper name for this? Now, this is when I would ask another student to unmute themselves and answer the question. I'm hoping that they might give some wrong answers, like a bike or just a cycle. But if they do get it right and say bicycle, I will then ask them, why is it called a bicycle? And they will respond, because it has 2 wheels. And from the starter, they will be able to connect that learning and go, right, anything with the prefix bi is all to do with the number 2, and anything with the prefix dec, or DEC, is connected to the number 10. So I'm going to briefly go back, everybody, to the decimal number system where we multiply each column by 10. Remember that? But in the binary number system, what number do we multiply each column by? And again, I would ask a student to unmute themselves, and they would tell me they would be 2. I would then ask them to then complete the column headings. I'll go from ones to then times 2 would be 2. 2 times 2 would be 4. Some might say 3. You can say no. You've got to avoid that misconception and multiply by 2 each time. So doubling each time. And then 4 times 2, 8, and so on and so on. So today, actually, we're going to be working with not just binary numbers that go up to 4 binary numbers, but also up to 8 binary numbers. But for now, let's just stick to 4. So going back again to our decimal number system, we know that each column can only contain numbers from 0 to 9. But in the binary number system, each column can only contain numbers from 0 to what? And again, I'll ask a student to unmute themselves, and hopefully they would say 1. If they said 2, again, I would nip that misconception at the bud and say exactly like it is in decimal, while that's to do with the number 10, you have 10 digits, but that includes the number 0. So you've got from 0 to 9, and in binary, we've got 0 to 1, so that's still 2 numbers, isn't it? So you've got 0 and 1, which are 2 numbers. So here we've actually got a binary number that is 0110. As humans, we find it really difficult to understand what that number means. So to figure out what that number is going to be, we have to convert that number to decimal. And here's how you do it. So it's very similar to how we did the decimal number on the left-hand side. We counted 9 units and 4 lots of 10. In this example, we're going to start from units again. We're going to say, well, we've got 0 ones. But we all know that when you multiply anything by 0, that's just 0. So I'm actually going to ignore that and move on to the next column. So we move on to the next column. We've got 1 lot of 2s. We move on to the next column again and add that to 1 lot of 4s. And we know that because the 8's column has got a 0 in it, we'll just ignore that one. Now what we can actually do is abstract this further, that is to ignore the irrelevant detail, because we know that anything that's multiplied by 1 is just that. So if we've got 1 times 2, that's just 2. If we've got 1 times 4, that's just 4. So we could just write it like this. It's a lot simpler, it's a lot quicker. But we know that addition is 6. Now, that binary number there, 0110, is actually equivalent to the decimal number 6. Now I'm going to go through one more example, and this is very similar to what you'll see on the worksheet that you're just about to start to complete. So you can see here that you've got the binary number 10010110. And this time you've got 8 binary digits. So that not only goes from 1, 2s to 4s to 8s, it carries on doubling to 16s, 32s, 64s and 128s. We're not going to get any bigger than that, so don't worry. That is probably one of the hardest questions that you'll have to do. And I'm going to go through that with you now. So actually working out the answer goes like this. So I've done the working at the bottom there, but what I did was I counted 1 lot of 2s. I ignored the 1s because there's a 0 in there. Then I counted 1 lot of 4, 1 lot of 16, and 1 lot of 128. So wherever there's a 1, that's what I'm adding up. So you can see there in the working, it says 2 plus 4 plus 16 plus 128. When we add all those up, we get 150. Now, by the way, when you're going through these questions, you can use a calculator on your computer or on your phone. That's absolutely fine, or a calculator that you've got in your pencil case. What I'd like you to do now is download, open and complete the worksheet called Year 7 Binary to Decimal Conversion Worksheet. All of us should be able to do the green questions. Most of us should get the orange questions done, and some of us will even get the red questions done too. There is also an extension of the task at the bottom of the worksheet. Now here is where I would make sure that they've been able to download the worksheet. I would put it in their chat group But at the moment, I'm just going to show you what the worksheet looks like. So this is the worksheet here. Again, we've got that example that they've seen there. It's also going to stay on their screen here. So whenever they want to refer back to it, it is also on that screen, just in case they don't want to scroll up to the top. So they'll start with really simple ones here, doing the working out for really simple questions like this, and it will self-mark as well. So if I write in the correct answer on this one, press enter, it would give me a tick. And if I give an incorrect answer here, like 6, it would stay as a cross. As soon as I give the correct answer, it will give me a tick. It's all been differentiated from green questions to orange down to red. Get a little bit harder, a lot more addition to do, but the theory is the same. Down here is also an extension, which is where they are asked to investigate how to convert numbers from decimal to binary this time. So some of the higher ability learners may be able to sort of pick that up straight away and go, well, we have to reverse what we did before. Some might go onto the internet and actually investigate it on BBC Bitesize or wherever else, and hopefully be able to work it out and answer the questions there. These again are self-marking, and these will turn into ticks if they get that right. Let me just show you an example of that. So here we go. I'm hoping I get this right now. So the number 7 would be that. So after after 10 minutes of that task, what I will do is I will ask them to all go back onto Socrative. So I'll go back onto Socrative here. I will then go to my Socrative, go to launch, ask for a short answer, and I'll just say, well, answer number 3 for me. So go back to your worksheet and tell me what the answer was for question number 3. I will then start that. I was meant to ask for their names. I'm just going to finish that, do that. Again, yeah, launch. So require student names just to make sure that we know who's answering what question. So I'm asking them to answer the question, which was number 3. And if I go back to there, I'm hoping everybody goes back to their worksheet and tells me that the answer to that is 6. So they'll write in their name again and write the number down. Now for the first one that I ask, I'm hoping that everybody will get it right, or most people will get it right, and I can show the answers and show names. Again, the students can't see this part of it. I'll be able to see who's answered what and then be able to go forward from there. If most people, or sorry, all people, all of the students are able to answer that question correctly, I would just ask them to carry on with the task. The few that might get those 2 questions wrong that I would ask, so I'd ask for another one of the answers as well, maybe question number 5 or question number 6, and I would ask them to answer that. If there's a few that get those wrong, then I would ask them to stay on Teams. So go back onto Teams and I would share my screen and go over an example with them. So I would actually go to Excel. I would go down to sort of like a middling question, something like number 9 perhaps, and go through the steps with them again. Hopefully then that means that they can, hopefully that means that they can sort out any misconceptions they have, sort out any questions that they might have as well, and go from there. So I'll then ask them to carry on with the task for another around 10 minutes, maybe a bit less, and then I would ask them to go back onto Socrative where I would have launched the plenary activity. And again, I'm not going to shuffle questions because they go in an order, but I'm going to shuffle the answers and show final score at the end. And again, test student. So these questions are designed to test what they've gone through in this lesson, just asking them really simple questions all the way, and then starting to ask them how to convert as well. So I'm just going to go through these and give a bit of an explanation as well. So what are the only two numbers that a binary number can consist of? Zeros and ones. Convert the binary number in the image to a decimal number so they can view the binary number, have a little go, add them up, and they'll be able to see that that's the number 11. And that's number 15, and maybe some of them might start on this one to get them wrong, perhaps. So I'm just going to randomly answer a question, hoping it's not correct. There we go. And yeah, there you can see on the teacher screen that, yeah, they've managed to get the basics of it right, and maybe they struggled with a few of the slightly harder conversions where they got slightly bigger numbers. Maybe they weren't using a calculator. And here I want them to answer the question. So computers can only understand binary because, and they would obviously write their answer in here and submit it. Once they've submitted it, or give them the correct answer here, but I will also be able to go into their answers, so show the names, show their answer, and go through them, and if there are any misconceptions, then go over them just before the end of the class. Obviously, once they've completed that, I will then dismiss them.